All right. So this is basically about concepts and terminology. So what is an architecture? What's a framework of integrated transportation systems? This diagram is from the National ITS architecture. It looks at all the subsystems that are in the architecture, or physical objects that are there. You can see that they're grouped. We have centers, which we identify from a lot, especially when it comes to agencies. We understand we have an operations center, so transit, traffic, emergency operations. There's a lot of different kinds of centers in the transportation system. They're often connected to field devices that are out on the roadway. And those field devices will be anything from traffic signals to connected and automated vehicle roadside equipment to our ITS equipment, that's DMS signs, CCTV, the detection in the roadway. And then we have ways of interacting personally with this. So I may have my phone, my computer, my tablet. I can actually interact with these centers and sometimes with the roadside devices as well. And then the blue or purple subsystems are the vehicles. That's really an important part of what we're doing. We're interfacing with them and they're interfacing with us as far as operations is concerned. But we have all different types of vehicles: transit, maintenance and construction, freight, emergency, and commercial. There's all different aspects of what they do and what they interact with. It comes down to it in ITS. And then overall, there's this support, these green boxes up here, these physical objects up in the upper left-hand corner of this diagram. Those are cross-cutting, if you will. Remember, I talked about safety or security of information. Credentials management system. The security and credentials management system is a growing area that we're trying to really figure out how we're going to do this. But when you get on your phone and you do any kind of transaction on your phone, you're actually getting your certificate to exchange that information with another system. That's the kind of thing we're talking about with security and credentials management. So there's an aspect of that, how it interacts with all these other. We want to make sure that the roadside devices are secure data, the vehicles that are producing data, that there's security there, the personal devices that we interact with that. There's also data distribution. We want to monitor these systems. When we start talking about connected and automated vehicle map system, map updates, we want to see the configuration of that intersection, be able to give that to a vehicle approaching that intersection. So we know what lane they're in, they know the configuration and geometry of the intersection. And that goes hand in hand with providing stat data, signal phase timing data that maybe they're just looking at counting down to the signal change, okay, phase change. And that gives them an understanding of whether they're going to make it through that intersection or not. They make a decision. So there's all kinds of things associated with that. From the standpoint of the map update system is part of that entire thing. So these are all connected. This is the highest level you really look at the national ITS architecture. But it's identifying the systems, and in turn, identifying systems, we identify organizations that are associated with that. So we have institutional layers to this. Each one of these physical objects has functions that it performs. So there's functions performed are identified in the architecture, so we know what we're doing. Different functions for different services that we provide. And one of the biggest the important parts of the architecture is information exchange. This is, ITS, Intelligent Transportation Systems, I always think of as integrated transportation systems, because that's what we're trying to do. We're sharing information, tying it all together. So the information exchanges are incredibly important to how we develop our systems. And that leads us to standards, communication standards, as we go down to project implementation. So if we take this national architecture, we create a regional vision based on that in functional terms. This is all about what? It's not about how. It's not about the technology. It's about what we need to do, the functions we perform to address the issues that we have in the transportation system and need to manage. So why do we have an architecture? Well, it's really looking at the region's technology plan. What are we planning on deploying? What problems do we have that we need to address with that technology in the implementation? So it gives us a platform to have conversations about those very things. What are we going to implement? What services do we need to provide to address those problems? helps us planning the projects out. So we get this bigger picture of what we're doing in the region. And now we can start to focus on the projects that fill the gaps of the issues that we need to solve. By also looking at the entire thing, the entire region, we have a tendency not to duplicate systems. We can build one system that satisfies more things than just a stovepipe that we would have thought about before. And that gets a lot back to the institutional integration we need to achieve. We need organizations to be talking together about what we're trying to solve in the region. And this opportunity to share information again, who's collecting what? You already may be collecting something in your system that some other organization needs, but why do we need to duplicate that? We want to share that information. The bottom line is there's federal requirements for architecture. If you're using federal funding for an ITS project, there's a federal rule that requires the use of representation in an ITS architecture. I always put that last, because I don't feel that that's necessarily that they should be the driver. There's a lot of good reasons to be doing all the architecture, and the federal requirements are going to be there, yes, but I don't think that should be driving what we're deciding. That's just, we're satisfying it as we go because of good thoughts that we need to go forward with architecture. Now, if you had an architecture, why are we updating it? Well, we're updating it because it's important. Things change. I think it was 2014 when the architecture was last updated. Yeah, and we had some things, conversations along the way between now and then, leading up to this update. But there's a lot of things that changed. We saw that with projects that have been implemented since that time frame, and new ideas and new approaches have come along. But also, we want to be using the latest information when we start looking at planning. We want a baseline to work from for planning. This is what we have today. This is where we're going. If something new happens, we want to make sure we can adjust that. So we base our architecture on this national ITS architecture as a reference, or what it's called now is the Architecture Reference for Cooperative and Intelligent Transportation Systems, ARCIT. So it's been around since 1996. That's when it was first released, the national ITS architecture. It's given us the definition of the ITS terminology, so some basis to work all that from. It's a guide for ITS deployment, so we can look at with the functions we need to put in place and the systems that we need to define around that. And then as the technology comes along that makes that possible, we can then go to implementation. It helps guide us to that. It's in 4 different views. We used to look at this content in that different way in the national architecture. The thing we associate most is the physical view of the architecture. That associates with the things we see in the real transportation world today. That first slide I put up with all the different physical objects, we can relate to what those kind of things are. Underlying that physical view or physical components of the architecture is that functional view. Those are the functions that are performed within those systems that actually make things work. On top of that, we have this enterprise view, and that's the institutional layer. Who does what? Who owns, operates, maintains, has agreements with. Those are all laid out in the enterprise view of the architecture. And then finally, the information exchange is where the heart of the architecture really gets going. And that communications view then lays out how we move information from one system to another. And from that standpoint, we get into standards when it comes down to it. So these architecture content's all available at archit.net. You can also get their archit.org. But it has all the content, the guidance for the use, and then the software tools we're using later on are all available there. So this has been around for quite some time. I've been around with this since 1996. So it's evolved dramatically. It's not that we put in a paper for ITS America next spring and we said it's not your your parents' architecture anymore. It's not the same thing it used to be back in 1996. It keeps evolving as we go.
Yeah, there seems to be a couple of comments in the chat. Want to just take a look at that?
Oh, those are just my notifications.
Oh,
okay.
Okay.
Well, sorry about that. Thank you.
That's okay. Thank you. So the components of our ARCIT, we have those physical objects we've already talked about those. Those are the colored boxes here on the screen. Inside those colored boxes, if you see there's color coding, all the green we showed before for the centers is all there. They're all the centers, the yellow for the personal objects, the field devices are in orange, the vehicles in blue. The white boxes inside each one of these that are shown are those functional objects. Those are the functions that are functional view of the architecture. This overall picture is for a service that's provided. So we have this big picture of architecture, all these different systems, all these different functions. We're not grabbing a hold of everything because we can't. It's too much to grab a hold of. So we have things called services, and those are collections of the physical objects and the functional objects, as well as the information exchanges that actually deliver a specific service. So you think of it as a slice of the architecture or if it's specific capability we want to have or service we want to provide. So these keys of information exchanges, all the red lines on this particular diagram, there's some black ones as well. There's codes behind that about what those really are. We see that we have travelers, we have drivers on this diagram. So there's a human element to it. We call those terminators because they sit on the boundary of the architecture. We don't model them as far as their functionality, but we have an interface with them from the ITS standpoint. So you can see that the driver will provide input to the vehicle and the driver gets updates to the vehicle. There may be a thing like a DMS sign and you see the drivers looking, you can tell they're getting information from the DMS sign, it's represented, that's how that's conveyed. But there's not going to be a standard associated with that. It's just an interface that we show that there's exchange. We don't generally put the human elements into the regional architecture because when it complicates things and it doesn't necessarily add to what we're doing, but it does, you can reference that through the national ITS architecture. So these are the building blocks: physical objects, the information exchanges, and the services. That's what we use to build the architecture, what you have in the Indianapolis architecture right now. So just this note at the bottom, just want to call it up one more time. This is architecture's functional representation. It's not about the technology. You're going to come up with a functional representation and it will stand the test of time. You're still going to perform the same functions, but you may apply different technologies at different points in time, depending on what's available. You want that flexibility. That's why architecture helps with planning going forward. You don't have to do it today, you can't do it. But if you say, I'm going to do it with loops in the roadway, and I wait 5 years, how much different kind of technology do we have today that we can do vehicle detection? I mean, video, acoustics, radar. It grows dramatically, and now we're not even talking about having to have that kind of technology. When we start putting vehicles out there, we can actually get the same kind of information from those vehicles directly. So that functionality doesn't change; it stays the same. I still need to surveil the traffic conditions, but I can get it from different sources as time goes on. Those services I talked about, there's 156 services defined in the ITS architecture. What we try to do is categorize them and group them so that they're easier to find and drilling down. I'm going to throw something on the screen from the national architecture. So these are all the services that are in ARKit. Okay, if I click on any one of them, I'm probably going to click on one I don't want to click on. Those same structures you saw on the previous slide are all there. I can drill down. You can see the categorization here that I showed on that the bubble slide. So I can drive down if I want to get maintenance construction. This is the set of maintenance construction services that I have to choose from in the architecture. Clicking any one of them gets me into those specific information there. So there's a breakdown of that. And we're going to be going through that a little bit more as we go into that exercise later on in the training. So I think we're doing pretty well on time. I'm gonna just walk you through just so you know where things are, just quickly on the architecture market site, because you'll use it as a reference as you go through. So the site is set up with these pull down tabs when you pull down this first one, you get the service packages that we just went to, showed you that list. The views that I talked to you about before, those are all contained here. If I go to physical view and then pick up the physical objects, I can look at any one of those physical objects in the architecture and get further information about that. Let's see. Management Center. I get the understanding of what other physical objects or services it's associated with very quickly. So if that was my entry point, I can then look at all the different services that I'd be involved in. Under the architecture use, we're going to be going through a lot of this today in the next module. It talks about in ITS planning and its regional architecture definition, regional architecture use, and project development. So it has application. Again, we'll be talking about that just so you know where these are. There's a resources tab. You can download the databases. I wouldn't necessarily recommend that from the net market standpoint. You'll need Microsoft access to actually do anything with them, and I don't know that it will actually, unless you're really into Microsoft access, that would be rather confusing. But there's also documentation associated with it, and here's the tools that we're going to be walking through today in particular. There's also, I wanted to make sure you are aware, there's further training courses regarding architecture available on this website. These are all online. You actually get credits for it. You can get PDHs for that. So that's also available. And then there's also always terminology that you can get. And one thing I wanted to point out here, if you can always contact the National Architecture team. You can answer questions all the time about doing regional architectures, any kind of concept that are confusing to you, something that didn't work with the software. Feel free to reach out to us and the team will get back to you.